Let's say we define the random variable capital X as the number of heads we get after 3 flips of a fair coin. So given that definition of a random variable, what we're going to try to do in this video is think about the probability distribution. So what's the probability of the different possible outcomes or the different possible values for this random variable? And we'll plot them to see how that distribution is spread out amongst those possible outcomes. So let's think about all of the different values that you could get when you flip a fair coin 3 times. So you could get all heads, 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 heads. You could get heads, heads, tails. You could get heads, tails, heads. You could get heads, tails, tails. You could have tails, heads, head. You could have tails, head, tails. You could have tails, tails, heads. And then you could have all tails. So there's 8 equally, when you do the actual experiment, there's 8 equally likely outcomes here. But which of them, how would these relate to the value of this random variable? So let's think about what's the probability. There is a situation where you have 0 heads. So we could say, what's the probability that our random variable x is equal to 0? Well, and that's this situation right over here where you have 0 heads. It is 1 out of the 8 equally likely outcomes. So that's going to be 1 over 8. What's the probability? What's the probability that our random variable capital X is equal to 1? Well, let's see. Which of these outcomes gets us exactly 1 head? We have this one right over here. We have that one right over there. We have this one right over there, and I think that's all of them. So 3 out of the 8 equally likely outcomes get us to 1 head, which is the same thing as saying that our random variable equals 1. So this has a 3/8 probability. Now, what's the probability? And I think you're maybe getting the hang for it at this point. What's the probability that our random variable x is going to be equal to 2? Well, for x to be equaling 2, that means we got 2 heads when we flipped the coin 3 times. So that's this outcome meets that constraint. This outcome would get our random variable to be equal to 2. And this outcome would make our random variable equal to 2. And this is 3 out of the 8 equally likely outcomes. So this has a 3/8 probability. And then finally, we could say, what is the probability that our random variable x is equal to 3? Well, how does our random variable x equal 3? Well, we would have to get 3 heads when we flip the coin. So there's only 1 out of the 8 equally likely outcomes that meets that constraint. So it's a 1/8 probability. So now we just have to think about how we'd plot this to really see how it's distributed. So let me draw. So over here on the vertical axis, this will be the probability, and it's going to be between 0 and 1. You can't have a probability larger than 1. So just like this. So let's see if this is 1 right over here, and let's see, everything here looks like it's an eighths. So let's put everything in terms of eighths. So that's half. This is a fourth. That's a fourth. That's not quite a fourth. This is a fourth right over here, and then we can do it in terms of eighths. So that's a pretty good rough approximation. And then over here, we could have the outcomes. Outcomes. And so outcomes, I'll say outcomes for, or let's write this, so value. So value for x. So x could be 0, 1. Actually, let me do those same colors. X could be 0. X could be 1, x could be 2, x could be equal to 2, and x could be equal to 3. X could be equal to 3. These are the possible values for x, and now we're just going to plot the probability. The probability that x has a value of 0 is 1/8. So I'll make a little bar right over here that goes up to 1/8. So actually, let me draw it like this. So it goes up to, so this is 1/8 right over here. The probability that x equals 1 is 3/8. So that's 2/8, 3/8 gets us right over. Let me do that in that purple color. So probability of 1, that's 3/8. That's right over there. That's 3/8. So let me draw that bar. And just like that. The probability that x equals 2. Probability that x equals 2 is also 3/8. So that's going to be that same level, just like that. And then the probability that x equals 3, well, that's 1/8. 1/8 is going to be the same height as this thing right over here. So actually, I'm using the wrong color. So it's going to look like this. It's going to look like this. And actually, let me just write this a little bit neater. I can move that 3. So cut and paste. Let me move that 3 a little bit closer in, just so it looks a little bit neater. And I can move that 2 in actually as well. So cut and paste. So I can move that 2. And there you have it. We have made a probability distribution for the random variable x. And the random variable x can only take on these discrete values. It can't take on the value half or the value pi or anything like that. And so this, what we've just done here is we've just constructed a discrete probability distribution. Let me write that down. So this right over here is a discrete. The random variable only takes on discrete values. It can't take on any value in between these things. So discrete probability distribution for our random variable x.